Hello, everyone. My name is Geoffrey Blair, second year Master of Environmental Science student, focused on urban sustainability and resilience, and also a student member of BIOMES committee. This is the first seminar of the 4 seminar series. So before introducing my guest, I'll briefly introduce BIOMES. So BIOMES is basically a YSE flagship seminar series featuring community-sourced interdisciplinary presentations on research, policy, and activism surrounding pressing environmental issues. And our main goal is to inspire and inform conversations within the YSE community. So building on this, I'll introduce our guest speaker for the first seminar. Our guest speaker for today is a lecturer in Yale College and a research fellow at the Harvard Kennedy School. At Yale, he teaches the world's first undergraduate survey course on climate engineering. That course material was published in a book form in March 2022 by the Cambridge University Press under the title Pandora's Toolbox: The Hopes and Hazards of Climate Intervention. He has published papers on the aeronautics, cost, and governance of solar geoengineering and presented preliminary designs for high-altitude research aircraft and hydrogen-powered airliners. He finished his business career in private equity with a New York-based company, New State Capital, and previously served as chairman and president of PEMCO World Air Services, chief operating officer of Atlas Air Worldwide Holdings, and president of the Flight Training Division of the Boeing Company. He holds a BA in history from Yale and an MBA from the other school in Boston, which is Harvard. Fellow YSE is my worksmate. And those joining from Zoom as well, there will be Q&A. If you have any questions, just post it in the chat box and then we'll respond. So I humbly introduced Worksmate.
So thank you, Geoffrey, for that introduction. Thank you all for being here. Thank you to Yale School of Environment and the BIOME series for having me. And thank you to 2020 graduate from the YSE, Umang Badarai, who helped me assemble this deck and assemble the thoughts behind it. So as Geoffrey mentioned, I've recently published a book on climate interventions, both carbon removal and sequestration on the one hand, and solar radiation management on the other. I teach a course on all of this material in the college here at Yale. There we go. So my talk today is on the topic of, is solar geoengineering unethical? And I am thinking a lot about this question. I have been pondering it for a couple of years now, and I'm ready now to write a paper on it, and I'm trying out with you today the material in that paper. First of all, solar geoengineering. This is the artificial volcanoes idea, aerosols sprayed into the lower stratosphere with the intent to deflect 1 or 2% of the incoming sunlight. If we did this at all, we would do it continuously for decades, year after year. We would likely commence with sulfur, although one might evolve to other materials thereafter, but sulfur is the material that Mother Nature uses for this purpose, and so we know that it is native to the stratosphere. We know that it deflects sunlight in the way we would seek, but one might evolve to other substances thereafter. This would have global effects, but probably heterogeneous ones. So it wouldn't necessarily affect the whole world in the same way everywhere. Umang and I have a paper being published tomorrow that may be in the press Friday, we'll see, on the possibility of doing this just at the poles. So one doesn't have to do this globally, but most programs anticipate that one would do that. It's pretty certain that it would result in cooler temperatures, but it's also pretty certain that it would not result in the status quo ante. It wouldn't repair the climate everywhere in the world to the way the climate used to be. And there are myriad risks associated with this. Many reasons this could be a bad idea. Known bad physical consequences. There are bad stuff we already know this would do. It would heat the stratosphere in ways that would goof the climate around a bit. Sulfur is the stuff that causes acid rain, so that can't be good. It might slow or at high levels of magnitude even reverse the recovery of the ozone layer, so that would be bad. And that's not the end of the list by any means. There almost certainly are unknowns as well, or at least we should go into it anticipating that it might do bad stuff that we don't know about or intend. It's a risky experiment with the only atmosphere we have. It could lead to political conflict, either due to divergent climate preferences or legitimacy questions about this. There are equity and justice issues that this could arise, that this could create. So all sorts of reasons why we're not about to go out and charge forward and do this. But as well, solar geo labors under an ethical cloud. Even if it worked as intended, even if all of the empirical questions that I was talking about on the prior slide were answered in the affirmative, there's still a question as to whether this is somehow ethically tainted to deploy and maybe even to research. Some of you may be aware there's a non-use agreement, open letter that was circulated at the beginning of this year among academics around the world that frankly is really a non-research letter or plea rather than simply a non-use plea. The perceived ethical taint limits scholarship and funding in this field, generally in the world, but particularly here at Yale. I don't know of any faculty members that are working on this at Yale, and I think there should be. So I'm trying to answer the question, why does there seem to be an ethical cloud that hangs over solar geo? And I'm going to go through that, but at the end you'll tell me if I've straw-manned or if I have missed arguments that you might have advanced, once again, that are ethical in nature rather than empirical. But most of the ethical objections that people have to solar geo are old ones. They're as old as the idea of solar geo is 20 or 30 years old. And they were conceived, in my view, in an era of climate naivete, when it was believed that substantial climate change could be avoided. Many of you may still believe that, but I do not believe that. I'm afraid it's going to get much warmer, and we are going to need, there's no question that we need to try to prevent that with every fiber in our beings. None of this is meant to imply anything other than that. But I'm telling you, I think we're going to lose this game, and that the world is going to get much hotter than people intend. And so ethical thoughts that were developed when we thought we could utterly avoid climate change, I think no longer confront the reality that the next generations are likely to confront. But what I've got here is the curves from the 2018 IPCC SR 1.5 report that show the emissions pathways that would be necessary to stay on the 1.5C aspiration that is incorporated in the Paris Agreement. And the curves, there are different ones, but they all broadly share the feature that in 2020, 2 years ago now, we were going to get on a luge-like plunge and cut our emissions in half by 2030 and cut them entirely and get to net zero by mid-century. And that's what would be needed in order to stay on the Paris goals. In 2010, when these ideas were first formed, as Kyoto collapsed and people began to plan for Paris, this may have seemed like a plausible guess as to what might happen in 2020. But the more recent AR6 report, still unfolding, the final chapter is meant to come out at some point this fall, but this is from the Working Group 1 report that came out last fall. This shows a different array of emissions pathways. You'll note that the two on the bottom get below zero in this century and are broadly Paris compliant, I'll call it. There are two on the top that blow the lid off of our emissions, but focus on the middle one, which per their term is the middle of the road pathway, as the IPCC is now portraying it. This middle of the road pathway results in a temperature differential relative to the late 19th century bench line of plus 2.7 degrees in the latter 2 decades of this century. And it's not yet at net zero by 2100, meaning there's more warming yet to come. So if this middle of the road pathway proves to be a prediction, but it isn't a prediction, it's one of many scenarios. Nonetheless, if it did, this would be a 3C-ish temperature anomaly by the time we might hope that the emissions line finally gets to net zero sometime in the next century. Part of the reason that that depressing pathway is nonetheless what the IPCC is now characterizing as the middle of the road is this slide, which demonstrates that more than 80% of our primary energy supply still today derives from fossil fuels. Solar and wind, you're going to say, wake, you dummy, don't you know about solar and wind and their growth? You can hardly find solar and wind on the top of this chart. They're way up there, those little slivers. They are still around 3% of primary energy supply globally. Fossil fuels is 80% still. It has been your whole life. It has been my whole life. It was my father's whole life. It's going to be very hard to change that. This is another graph created by Carbon Tracker that shows on the one hand a similar luge-like Paris-compliant emissions pathway in this decade, compared with the pledges and targets that were made in 2020. Those pledges and targets were updated in 2021, so this range here would be about 15% lower if we used the latest targets, but many of the pledgers won't keep those pledges. So using this as a prediction for what will happen is problematical. The punchline, though, is this line and this line are still very divergent. And what many people are projecting for the coming decade or 2 or 3 is roughly level emissions rather than luge-like plunging emissions. And yet we must win this battle. None of what I'm talking about here is intended to dissuade or distract from that. There's only one door to an acceptable climate, and we got to go through that door, and that door is net zero. But you'll notice I've taken the time scale off the bottom of this. I don't know when we'll get to net zero, but when matters hugely. Because this is a tank and flow problem, as I'm sure you all know. It isn't the amount of emissions coming out of the spigot or out of smokestacks and tailpipes that informs the climate. The climate is informed by how full the bathtub is. So if we are emitting at roughly 50 gigatons of CO2 equivalent today, and we cut it in half, which would be enormous, what those curves ask us to do by 2030. If we cut emissions in half, what's happening to the water level in the bathtub? It's still rising because the drain is essentially clogged. Mother Nature's ability to remove carbon dioxide from the atmosphere is super slow. Methane, highly, high radiative forcing, but goes away in a decade-ish. N2O in a century-ish. But CO2 hangs around for centuries to millennia. And so whenever we finally get to net zero, turn the spigot all the way off, not halfway down, all the way off, only then does the bathtub stop filling, because the Mother Nature's drain is clogged back to units this drain runs at less than 1 gigaton a year. So right now, 50 in, 1 out, big problem, bathtub still filling. So this is the worst news in this presentation. After we get to net zero, temperatures simply stabilize. If you walk out on Prospect Street and ask someone who doesn't go to YSE what happens when we get to net zero, their answer is, we're done, right? We're good. We're only good if we stopped filling the bathtub at a level that we were good with. But if we keep filling, however much we fill the bathtub, that's the level of concentrations that the future will have to live in for centuries. So after net zero, again, temperatures merely stabilize. They don't rush down. And if it's temperatures that inform climate damages, and it's only partly that, but it is to some degree that, then if temperatures don't go down after net zero, climate damages don't go down after net zero. In fact, if you look at the area beneath this curve, the aggregate damages in the century after net zero will be greater than those in the century before net zero. That's a hugely profound thing to wrap one's head around. And I don't think the general public understands this very well at all. And even that is optimistic because it assumes no big tipping points are encountered. But you all are aware that there may be big tipping points. The AMOC shutting down is a terrifying one. Collapse of ice sheets is a terrifying one. And if any of these tipping points are passed before we get to net zero, temperatures may in fact continue to increase rather than merely stabilize. So the punchline of all of that is there's more than one climate crisis that we're going to need to figure out how to address. Problem A is how to reduce our emissions as quickly as possible so that we reduce the amount of climate change that the world will experience. That's the priority, nothing changes that, and the tool by which to do that is mitigation. But there is a problem B, which is that some climate damages are already accruing and they will continue to accrue. And so in addition to mitigation, we've got to employ adaptation to contend with those climate damages that are coming soon. But there's also a problem C and a problem D that are mostly after net zero problems. Problem C is that if we fill the bathtub, as I fear we will, future generations will live in a too hot world. And they may then decide they've got to repair the climate after we have ruined it. And they would repair it by vacuuming carbon out of the climate system and burying it back underground. So direct air capture and geologic sequestration. And then problem D. So if you're 20 years old in the net zero year, whenever that is, you're going to say, well, great, we may have invented ways to repair the ruined climate over the next several centuries, but I'm only going to live another 60 years. What's going to solve the climate problem in my lifetime? None of those things, but maybe solar geo could, because maybe it could decouple climate damages from future high concentrations. So solar geo is not plan B for problem A. It's not an alternative way to get to net zero. It's plan A for problem D, how future generations might survive in a too hot world. So with all that background, let me move on then to the common ethical objections that are advanced vis-a-vis solar geo. The mother of all ethical objections to solar geo is moral hazard or mitigation deterrence. And moral hazard comes in a couple of different flavors. The first one is irrational, I'll call it, moral hazard or mitigation deterrence, where simply the idea that solar geo is a possibility may lessen the urgency of mitigation, and it may knowledge that solar geo is a possibility may reduce or slow our mitigation and therefore make the ultimate problem worse. If we think about that and deconstruct that idea a little bit, it really has two premises upon which it relies. The first one is a normative assertion, which is that exporting climate damages to the future while enjoying the energy services today, that would be distributionally unethical. And I think that premise succeeds. I think that would be bad. There's thereafter a predictive assertion, which is that when people hear about solar geoengineering, they will prefer it to mitigation. So let's test that predictive assertion. I've just described to you what solar geo is. Most of you likely knew about it before we got here. How many of you prefer solar geo to mitigation? How many think it's a better idea? We've got one hand out of 50 or 60. That prediction failed. And it fails over and over again. Every room I go into, that's the result of such a poll. Very few people hear about solar geo and think this is a better idea than mitigation. Might that change in the future? Maybe, but I spend a lot of time on this and nobody has articulated a rationale for why something that people mostly find sort of abhorrent today, they will suddenly rush to in the future. I used to say this prediction is simply BS. I'm now using the word unreliable, but we should stop predicting that people will suddenly, somehow fall into the trap that this is a better idea than mitigation. That isn't how the world receives this idea. An alternative flavor of mitigation deterrence is cynical mitigation deterrence. It's the same lack of mitigation, but with a different intent. It's not that we are failing to think through the cost-benefit analysis. It's that we're intentionally trying to wound the future. We're doing a bad thing here. We're currently wounding the future by continuing our emissions, but the cause of that is denial, ignorance, inertia, lack of investment, but not malice of intent. No one in the solar geoengineering community is promoting solar geo for this purpose. We're not seeking to wound the future. But somebody might seek to wound the future, and that is the fossil fuel industry. So there's another flavor, sort of deceived mitigation deterrence, where solar geo is cynically represented as a cost-free workaround, more clean coal. I think we should assume the fossil fuel industry will do this. But even if we stipulate to that, does that mean that our response should be to abandon this because we think they may misrepresent it in the future? That can't be the response. If solar geo has any utility at all, and I'm going to keep saying I don't know if it will, but if it proves to be a useful tool, then we must be prepared to combat its mischaracterization in the public square. Another concept that underlies the mitigation deterrence idea is the idea that this will be a material causal factor as to why we slow our mitigation. And that just doesn't stack up to me. I've put here my subjective top 10 impediments to rapid mitigation, and every one of them is awesome. How are we going to stop population growth? We're just not going to. It may by itself, but we're not going to manage that for the purpose of climate. We're going to talk people out of economic growth? Not likely. The collective action problem, how we convince everybody to do the right thing if we do it. Energy security considerations are coming home to roost in Europe right now, and people are remembering that Carbon is not the only criterion by which energy decisions will be made. Transition costs, stranded workers, hard to remediate sectors like my industry, the aviation industry, insufficient transmission and storage capacity, weak global governance, the Paris Agreement is not yet working, technology gaps, weak incentives intergenerationally. Compared to each of these and others you might add on the list, the likelihood that the knowledge of solar geo is going to be a big causal impediment to mitigation, I just don't see it proving to be that important. There's also the hubris argument that we ought not to play God and cavalierly spin the global thermostat. Doing so tempts fate. Icarus deserved his fate, which is a compelling argument, so long as there is nothing on the other end of the scales. All things being equal, we should opt for modesty. That's the precautionary principle. But what if millions of lives are at stake? What if heat is destroying societies and ecosystems? In such circumstances, we turn out often to want to play God. And I think saving lives, if it came to that, would trump modesty. There's also a legitimacy deficit. Solar geo would be impossible to govern, some say, and therefore there's no purpose in pursuing it. In my view, that is deflection and exaggeration. Would it be hard to govern? Absolutely. But impossible? There's no data set behind that. Mitigation has proven to be impossible to govern. We looked at those charts earlier. Does that mean we should give up on it? So let me move from playing defense against the ethical assertions that others have made to playing a little bit of offense and making some assertions of my own. Firstly, there's a golden rule that I would suggest we need to adopt in considering solar geo, which is it's dishonest to compare engineered world to pristine world. But that's the comparison that people often make. Do you want to screw up the beautiful day we have outside? Why would you want to do that? Well, no one would want to do that. And so if the choice we had confronted was between pristine world and engineered world, everyone would choose engineered world. But that's not a meaningful appreciation of the dilemma the world might confront if it were on the cusp of solar geo deployment. The dilemma would be between runaway climate world and engineered world. A risk-risk trade-off in which the ethical considerations, frankly, mostly evaporate. At that point, the empirical questions would come to the fore. Will it save lives? Is the cure better than the disease? Can we justly govern it? But we must compare a solar geoengineered world to a world without solar geo, the same world without solar geo, not pristine world. I also push back against the idea of substitutability between mitigation and solar geo. They're not substitutable in time or certainty. The time for mitigation is right now, yesterday, in fact, this decade, next decade, next decade. Solar geo isn't a prospect in the first half of this century, and I should know, I'm the solar geo deployment guy. We're not anywhere near doing this anytime soon, and we must mitigate soon. So these don't compete with each other in the near future. Might they compete with each other in the latter half of this century? Maybe. But my guess is that if we do solar geoengineering at all, most of it would be done after net zero, when it can't compete with mitigation. So these things don't line up. They overlap perhaps, but they don't line up temporally. And as well, mitigation is a certain remedy. Solar geoengineering is an unreliable hypothesis. We don't yet know that this would be a good idea. So it's an uncertain tool for a different time, and therefore not substitutable. But my final ethical argument about solar geo, ethical argument in favor of considering solar geo is the hypothetical posed by the novel published last year by Kim Stanley Robinson called Ministry for the Future. It is a book whose initial plot device is a heat wave in northern India that kills 20 million people in 2 weeks. Now, this is science fiction, but scientists are not dismissing this as implausible. Maybe it's not 20 million people, it's merely 500,000 people. But if we have 500,000 people die in a heat wave, we will have loads of livestock and other things die in the same heat wave. And deadly heat waves would thereafter be a distinct possibility. It likely, if it happens once, it may happen again. So if you're in the room when the prime minister runs into the room and says, what do we do to prevent future heat waves? What tools do we have at our disposal? What are you going to tell her? Mitigation will have failed. If we're to the point of mass casualty heat waves, mitigation, there may still be mitigation left to do, but it won't solve next year's heat wave. Carbon capture would be way too slow to solve next year's heat wave. Again, centennial time frame for that. Adaptation, we're going to somehow change the economy of Pakistan to have air conditioning for everybody, not quickly. But solar geo could save those lives. There is a cohort of lives that nothing but solar geo could save, or at least it's the only tool we currently have on offer, if this terrible thing happens, and it may never happen. So is solar geo a good climate solution? Well, firstly, it depends on which climate crisis we're trying to solve. It's not an alternative path to net zero, but it could relieve heat stress and suffering. Do I believe in this solution? As a guy who's literally spending my entire life looking at this, not necessarily. I keep saying this cure could be worse than the disease. What I believe in is the problem. I think it's going to get hot. And I think future policymakers are going to demand, or may demand, planet cooling strategies. And solar geo is the least bad option we currently have on offer. So is solar geo unethical? If it were used to beguile people into slowing mitigation, then yes, I would deem that to be unethical. But there's no scientific or academic or policy constituency that is arguing for that. If it were governed unjustly, that too could be unethical. This must not be imposed by the global north on the global south. But if millions of lives were at stake due to heat stress, it would seem to be profoundly ethical, particularly if it is responding to demands from the global south for such relief. So is solar geoengineering unethical? It depends. Many assume that solar geo is inherently evil, that it can only be used to wound the future. But the ministry use case, in my view, is ethically pristine. Substantial warming is coming, and deadly heat waves may follow. We must defend solar geoengineering from misrepresentation both by cynical fossil fuel interests and by naive emissions pathway optimists. Like most technologies, the capacity for good or evil is not in the tool, but in the intent of those who wield it. So that was a lot to lay down on you. Thoughts, questions, concerns, objections?
Let's wait for the mic. We have people zooming in. It's coming at you.
A mic over here, please. And then is there a second question so we can pre-position the mic over there?
I have a question to do with what you were just talking about in Pakistan with the ACs in homes. And so it seems to me that you would need to weigh up solar geoengineering against adaptation and the cost of those things. It seems to me that actually putting AC in every home in the world would be a comparable effort, if not way less than solar geoengineering.
I haven't done precisely those numbers, but solar geo is so cheap that if we all pulled the money in our pocket now, we could afford it. Now, I'm joking, but solar geo is like 2 or 3 orders of magnitude cheaper than carbon capture or than mitigation. Comparing it to air conditioning in every home, I guess I haven't done that comparison. But one of the features of solar geo is it's unbelievably cheap in the toolbox of climate interventions. And I'm not selling cheap as a good thing. There's danger in the fact that it's so cheap. That could cause people to do it without the governance legitimacy that we would seek that it have. But there are lots of good reasons why we may not want to do this. Cost is not likely to be one of them.
Hi, thanks so much for your presentation. My name is Aidan. I think it's great that you highlighted saving lives and the potential for solar geo to save lives. I do think it's really effective at this.
You think?
I think it's really effective at this. One aspect I would be interested in hearing is whether you've also looked into the question of which lives it would save and like the equity aspect of this. So like based on my understanding, for example, the Mount Pinatubo volcanic eruptions are used as one of the most common researchers of injecting sulfates into the atmosphere. And I've read that it previously affected rainfall in the Sahel, as well as monsoons in India and various other parts of Asia Pacific. And so I've wondered also if you've looked into this equity aspect of which lives exactly solar geo would save and which lives it might sacrifice in the process.
I haven't looked into it deeply, but what has occurred to me, the reason I've conceived this paper and I'm giving this talk, is there is a temporal cohort of lives that solar geo might be the only tool that could save them. Lives far in the future might be saved by carbon capture, but the lives that might be at risk right around the time of net zero, it's at least possible that that temporal cohort of people who might die in heat waves or of other heat stress at that time, solar geo might be the only tool that saves that cohort of lives. But I think you're not asking a question temporally, but sort of in other ways. The likelihood is the poor people in the hot places of the world who can't afford air conditioning are the people who are most likely to be at risk. But I'm not trying to advance that argument. I'm not saying this is something for the poor. Other people have said that. I think that's getting a little cute. If this works, it would work for everybody. And but which lives would it save? It's most likely the most vulnerable lives.
Thanks for a great presentation. Interesting. I mean, I guess you invite sort of feedback and reactions. I guess what I would just say is, I think you've done a wonderful job at convincing me or maybe others that solar geoengineering, it may be sort of like an important tool to address the climate change problem. But I was wondering if you could push a little bit more about what you mean by ethical. It seems to me that the way you set up the problem is it ethical, sort of has a clear answer to me, in that you have a utilitarian definition of what is ethical or what's not. Saving lives and just thinking about these trade-offs. And when I think about what's ethical, I don't sort of just think of it as like, just because it's utilitarian in the sense that it's the only solution we'd have because we're going to burn up otherwise. I don't necessarily think of that as the criteria that I find that maybe makes it most ethical. There's lots of things that people could do that would save their lives or not, and they would actually prefer to sort of satisfy their ethics instead of saving their lives. So I'm just thinking in terms of the choice of ethical, like is it a necessary tool for like human civilization? Yes. That doesn't, I'm just, there's different like ways of thinking of determining what is ethical or what is not. And I'm not a philosopher, so I can't articulate exactly what they are, but it seems like you're appealing to one in particular.
So that's fair. And I attempted to treat a non-utilitarian concern about playing God, but I answered it with a utilitarian. So you're right that I'm a utilitarian, first and foremost, maybe. If lives are at stake, I'm pretty compelled by that. You know, saving lives rises to the top of the priority list. So if people think that they know they could save the lives, but they don't want to because it violates some other ethical precept, I'm pretty compelled saving the lives, but that's me. It would be valid to view it differently. And you are pointing out to me that I addressed my non-utilitarian concern with a utilitarian answer, so maybe I've got to think that through.
Hello, thank you for your talk. My question is about the state of the research, and in a case where we have runaway climate change today, where we're crossing all the tipping points today, when could we deploy it on a global scale?
I used to say there's a decade time to launch temporal barrier that we confront. I'm probably about to write an article that contradicts that a little bit. If we wanted to do the perfect thing, what the scientists have been telling us they would want us to ideally do, we've got another hand here if we may. Got it. The ideal deployment concept is 20 kilometers high at 15 north, 15 south, 30 north, and 30 south. To get to 20 clicks altitude at 15 north and south, you need a new airplane that does not now exist, and to get there with a big payload. So it requires a decade to develop that airplane and build a fleet of them and get the bases built and so on. But it has been pointed out to me, and it's true, you could have globally impactful programs way sooner if you're willing to live with suboptimal programs. So instead of 20 kilometers at 15 north and south, we're going to go to 15 kilometers at 35 north and south. Now that won't deal with the warming in the tropics to anywhere near the degree, because this stuff flows poleward once you deploy it. So if we're deploying at 35 north and south, more or less where we are here in New Haven, it'll solve the problem poleward of here, but it won't solve the problem equatorward of here. Now it will indirectly in a couple of ways, so it's not a total abandonment of the tropics, we'll call it. But could you do that in a couple of years? Yeah, actually you could. And so I intend to write a paper that will outline what that deployment program would look like. I'm not advocating for such a deployment. The role I'm trying to play is to help the world understand what realistically is and isn't possible. And one could begin with that suboptimal deployment for the decade that it takes you to build the fleet to then do the optimal deployment.
Thank you very much for bringing this topic here. I think it's very important to also discuss these interventions. My question builds a little bit on what Leopold asked.
If you'd speak up a little bit, I'm an old man.
Okay, I'll try. So my question builds a little bit up on what Leopold just asked. And it's also a bit ethically related. So when people are getting very hot, I suppose they're also willing to pay a lot of money to get quick solutions, right? And I'm sure there's going to be businesses that have thought about this as well. So what I'm wondering is there any form of business that already owns patents to these kinds of solutions and that are actually thinking about marketing this and making money? It's like a doctor, you know, when people are very sick, they're willing to give everything. So
there, the short answer to your question is no. I'm unaware of any businesses that are pursuing this, which is kind of a shame because I've been trying to convince some people to put money into it and I can't get them to do it. But people are, I think correctly, perceiving that this is decades in the future and not certain that it will ever happen. And so the idea that we're going to start investing behind this to try to make money, that idea at least hasn't arisen yet. The first thing that is needed, I'm immediately, I've done a lot of descriptive work on deployment, but what I'm shifting my focus to, in fact, is research and the aeronautical assets necessary to do that research. And right now, the only high altitude aircraft that can get to the altitude range that's relevant here are 7 aircraft, all of which are operated by NASA, which means all of which are under US sort of semi-military control. I think the world needs a fleet that the whole world can operate that's much newer than these NASA aircraft for the purpose of geoengineering research and stratospheric research more generally. So I'm beginning to think about how one might do that. But that's not trying to get into the business of geoengineering. I don't think anyone is yet smelling profit in this. Moreover, I suppose I have a very difficult time imagining a world in which governments would allow non-governments to do this. I think this will immediately be the province of governments. And if evil Bill Gates tried to do it with his BizJet, the US military would knock on his door and say, no, you don't. I think if country A tries to do it without country B, that likely creates tension. So I think this quickly becomes a multinational, global-ish thing, if it's anything at all. That UN entity might then hire companies to build planes and fly planes and so on, but that's not going into geoengineering for profit. I think this is, I have trouble conceiving of a world in which private actors do this, not at the behest of governments.
Hello. Hello, Wake. So thank you for the great presentation. A little bit about my background. I'm an atmospheric scientist, and so I kind of wanted to ask a question about the scientific implications. So in terms of just climate modeling and global warming modeling, in your presentation, you did mention a lot of the main emissions that we focus on global warming: CO2, methane, N2O, water vapor.
Yep.
But in terms of our projections for global warming, a lot of the uncertainty that we have is due to aerosols, just because we have a lack of understanding of all the different processes of what happens with these aerosols. A lot of different things, chemistry, aerodynamic properties, all that. So there's kind of still, science is lacking behind in terms of this research for aerosols.
Yep.
So kind of my question is kind of this idea of geoengineering. This is kind of, for me as a scientist, this is kind of like a paradigm jump over, we still have a lack of understanding for the natural aerosols that we have in the air. So my question is, in your opinion, why not actually put resources into kind of this kind of understanding the science behind the aerosols and what happens, rather than kind of moving past that and going into this geoengineering?
To do the latter thing, we would have to do the former thing. You're right that we have way too little understanding of the microphysics of aerosols in the lower stratosphere. There's huge amounts of research that, decades of research that would need to be done in order to constrain the scientific questions enough to the point where we would sensibly have the confidence to do this. But the sooner that we begin that research in earnest, the lower is the likelihood that in 2048, some prime minister just freaks out and says, I don't care that you didn't do the research. My people are dying, go. I do think we need to try to avoid that world. And so the sooner we begin serious stratospheric research related to this, but also related to climate issues more generally, the better. So I'm eager that we commence that research, and I'm trying with my colleague to facilitate that research.
Let's take one more question.
Great. I guess down here.
Yeah, so thank you so much for that presentation, and following off of a couple of the previous questions. So the way that you framed this obviously is as a very utilitarian solution that my impression of your presentation is that we would be using in a situation that was pretty much an emergency, right? We're like
Pretty much.
an emergency. So, or we're like perceiving that maybe there's going to be a heat wave in India, just the exact solution or the example you were using. And we need a really quick solution to save a relatively easily quantifiable number of people.
Yep.
And I'm wondering if the way that the trajectory that the research is going now, if you perceive being able to understand, or like that the science around this will understand the gravitas of the other negative impacts that could be caused by deploying this technology by the time that we would potentially have to use it. Because the way I'm looking at this is like, this is a Band-Aid solution to be deployed in an emergency, but it's a Band-Aid solution that comes with what seems like almost innumerable, potentially very negative impacts. And I'm kind of wondering if you can comment on the way that the understanding of those negative, the research regarding understanding those negative impacts is evolving, and how you see that going forward. Because it seems as though we might create a Band-Aid, we might deploy a Band-Aid, and then that Band-Aid might put far more than 20 million, to follow on that paradigm or on that example, far more than 20 million lives at risk. So yeah, I'm wondering if you can comment on that a little bit.
It totally could. I keep saying over and over again, I'm not clear this is a good idea. I'm not clear it's a good idea physically, but it also may create human conflict or change incentives and so on. There's loads of research that needs to be done on all of that, both scientific research, but also social science research. There's a whole governance structure that would need to be assembled to govern this that does not now exist. And it's sort of hard to, well, let me leave it there. It doesn't yet exist. So there's loads that needs to be done in this arena. I worry, so I have raised this in an emergency framing. I'm afraid that emergencies do sometimes drive things. The pandemic, created emergencies that caused people to do all sorts of things they wouldn't have done before. And we should hope that if we commence with this, it's done in a more thoughtful, proactive way to shave the top of the heat, shave off the highest temperatures for a few decades while we put other solutions in place. That would be a better way to do it. But this Ministry of the Future thing, which again is total science fiction, it would change the world more than 9/11, more than the pandemic. The idea that many people could die in India this year and Iran next year, would terrify the world. And so events might be driven in that way, but I hope they're not. I hope we get ahead of the research and figure out, create a thoughtful, well-governed program by which to do this. I mostly hope we don't ever do this at all. I expect you're all in the same place. I just look at the climate trajectory that we're on and I worry. Well, thank you kindly for taking the time.
And
Yes.
Wake, you're here at Yale, right? So they can reach you at that.
Sort of. You can reach me at this email address, and I'm happy to answer questions via email and offline, wake.smith@yale.edu.